In the past couple of videos, I focused mainly on the string class's replace first method and talked briefly about the matches method. In this video, I'll talk about other relevant string methods. The other class that makes significant use of regular expressions is the scanner class, and I'll also be demonstrating some of its methods as well. I've opened up the project from the last video, and I'm going to add new code into the main method. I'll start with a text block, the first 10 lines in Macbeth's Song of the Witches by Shakespeare. I'm just going to paste this in here. I'm going to use the split method to count the number of lines in this text. I'll create a string array called lines and set that to the result of calling split on the paragraph variable. In this case, I'll pass a string literal, the \n literal. This literal doesn't have any meta characters in it. I'll also print the number of lines. Running this code, I get a new line of output that says this paragraph has 10 lines. I can change that literal to use one of the predefined character classes. This is called the line break matcher and matches any Unicode line break sequence. If I run this, I'll get the same result as before. I can do something similar to count words, this time using the character class to identify white space. This is a \s, which matches any and all white space, including new line character combinations. I'll again print this count out, which will give the count of words in this text block. Let's confirm this works. We get confirmation that the paragraph has 57 words. Next, I want to use the replace all method to replace any word that ends in BLE with the word grub, G-R-U-B in capital letters. I'll call replace all again in a println statement. My regular expression will use the alphabetical ranges from A to Z for both upper and lower case. I'm going to follow that with a plus quantifier, which means that it has one or more characters, and they should be followed by BLE. I'll replace all matches with grub, but I'll enclose that in square brackets, just so it's easier to spot in the output. Will it work? Let's find out. You can see that trouble, double and bubble were all replaced with grub in this output. Let's now consider what methods on the scanner class can be used with a regular expression. I will create a scanner using this text block. I can just pass the paragraph to the constructor of a scanner. The first thing I want to do is print what comes back from the delimiter method on the scanner instance. I'm also going to call close on the scanner. There's a lot of debate as to whether this is necessary or not. Because the scanner constructor uses a string reader, it's technically not required, but since Java's own API documentation includes it in their code samples, I'll include it as well. You don't want to call close when you use system.in in the constructor, because that is the one I/O stream you don't want to close. If I run this code, I get a regular expression printed out. The delimiter method returns an instance of the pattern class, and I'll be covering this class in an upcoming video, but a string containing meta characters has to be compiled into an instance of the pattern class to be used. We've been looking at the API documentation for pattern to see what options we have. Now you can see that by default, a scanner is going to use Java whitespace as the delimiter for its next method. We can override this in several ways. Before I do that, I'll just see what I get with this default delimiter and use the scanner to print each delimited element. I'll set up a while loop that checks the hasNext method to decide if there's another delimited element. I'll set up a local variable element and assign the result of calling scanner.next to that. I'll print each element. I'll execute the code. You can see that every word in this paragraph gets printed on a new line. If I want to print each line, I could just use scanner.hasNextLine and scanner.nextLine. But instead I want to show you two other methods. First, I'll use the useDelimiter method on scanner. I'll insert that above this while loop. I'll pass this method the character class for a Unicode new line. Now if I run this code, my element is now an entire line in the paragraph, not a single word in the text. JDK9 introduced the tokens method on scanner, which returns a stream of string. So let me show you this. Since now our token is a new line, I'll comment out this while loop. I can replace the while loop with a call to the tokens method and use the for each terminal operation, printing each line. I'll execute this. I get the same output. I could also use a similar stream to count the words in each sentence using a regular expression. I'll use map here to create a stream from the array I get from the split method using the regular expression that splits by any number of space characters. The plus meta character is a quantifier, remember, meaning match at least one space or many. Finally, I'll just have that stream return a count. Running this now. I now can quickly see how many words are on each line. I'll change the stream again, changing map to flat map and removing the count terminal operation from the nested stream. This would print every word if I ran it now, so I want to filter this first. Here I'll use matches because I'm matching on each word, and I'll pass the regular expression I used earlier to match a word that ends in BLE. Let's see what this gives us. I only get one word printed out double. Can you guess why? It's because my paragraph is punctuated and my words include commas, periods, and also a semicolon. I could change my regular expression that I'm filtering by, but instead I'll show you another regular expression that removes punctuation. You can find this character class in the Pattern API documentation. I will put this one before the flat map call, stripping punctuation for the whole line. I can map my text line and use replace all to strip out the punctuation. Here, I'm using \p and in curly brackets an abbreviation for punctuation, PUNCT. So this is one way to strip punctuation. I will run this now. I get 6 words printed out that end in BLE. Before I end this video, I'll show you an example of the find inline method. This one is most useful if you're interested in the first line in your paragraph or text that's scanned. If you are reading in a file, for example, some files have a header row with information about the rest of the text, so that might be a good use case for this method. I'll first comment out the code that uses the tokens. I'll add a line that just checks if the first line has one of my BLE words. This printed double. It finds the first matching element and returns it. If I copy this statement and paste a copy right below, and run it again, I get a second double with a lowercase d. This method will return a null when it reaches an end of line. To check the information of the following line, I'd need to call next line. There are other methods on Scanner that use regular expressions, and one of those also returns a stream. I'll show you this one in a later video after I review the pattern and matcher classes in more detail. Okay, so I'll end this video here. In the next video, I want to give you a series of small challenges to test what you've learned, so I'll see you in that next video.